Hello everyone, welcome to tutorial channel of H.O.D College and hopefully you are doing well. Let's begin with the data structure. Data structure is used to make the logics, right? I mean you are not going for the coding or any programming language. Data structure specify each and everything, every concept in the steps. Okay, let's begin with the search process. What do you mean by searching? Searching is a technique in which you have to find an element from a list, right? It's very common and usually we do it every day. For example, you are in the library and you are looking for a book, okay? And you will start the process from the Almira first, then rack first, okay? You are going to search a book, okay? If it is not found, then you continue your search process, go to the second rack, then third rack and fourth rack and continuously, okay? Then you go to the second Almira, etc, etc, okay? So finally, at the end of this process, you will be within two results. Either you have a book found within you for which you are looking, or the operation is unsuccessful, right? Every search process is within two results. Either it is successful or it is a fail. So we can learn that when we start the search process, we have to begin from the beginning, right? You are going to search an element from the beginning of the list. Then if it is not found, then you move to the second element, then third element and so on. Hopefully you understand, okay? And while you are searching, you must stop your process as and when the element is found. I mean, when you found an element, you are not going with the search process, okay? You have to stop that. And if the element is missing in the list, okay, then at the end you get a result that element is not found. So in simple word we can say that either we are successful with the finding of element or it is a failure. Then let's begin with the algorithm. Okay, searching is of two types, that is a linear search and another one is a binary search, right? So first we are going to discuss with the linear search. As the name suggesting you that a linear search is used to find element from one by one, right? That is, you need to find an element beginning from the first element, then second element, then third element, and continue the process until you find the element or the list ends here, right? So we have the values here. Take a look. That is, the name of method we mentioning here is a linear search, right? So you can say another name like sequential search or whatever the name with you please, okay? And it have the parameters. That means you have to specify that there is an array A and the length of that element is n, and you want to search an element that is item, okay? So this whole process showing you that the name of method is a linear search, which can be another one, okay? And you have to specify the parameter, that is a is a list of element, right? And the value is n, that is total number of elements, and what you want to find, what you want to locate, that is the element item, okay? So in simple words we can say that we are going to search item from A having an element, okay? And when you have written this, you need to specify the definition. It should be around 2 to 3 lines, which can be your wording, okay? It's very simple. Like this method is used to find a value that we have discussed already from the array A and having with the n elements. N element you can suppose like 5 element, 10 element or 20 element, whatever the length it could be, okay? Just because it's a linear process, so we will start from the beginning. I mean to say from the first element. Now look at the steps, okay? So put the number of the steps and the first keyword will be start, okay? In any algorithm, whenever you are going to start, the first will be start, okay? It's very common. Number 2, let's take an index, that is set I is equals to 1. It means we are going to search our element from the beginning, so you can write I is equals to 1. The next element is you need to go through the steps, that is repeat while. Okay, repeat while means you have to repeat the steps until you don't find the element, that is I less than is equals to n. Now what is I here? I is the searching location from where you can begin. That is the first element. And what is the n? N is a total number of elements. As we have discussed already, that n could be 5 or n could be 10, whatever. Okay. So the location 1 will continue to increment until n is not find there. Okay. Let's begin. If a of I, right? What is a of I? That is from the list of elements, and actually I is 1, so you can consider I is 1. Okay. Now we are going to compare the elements if a of I is matching with item, right? So what we have done here, simple writing if condition, that your item is matching with the list, whatever the location is. Let's replace the value of I, suppose it is 1. This means you find your element in the beginning. Okay, as you start your search process, you find the element in the beginning. Okay, which is very rare. But let's take an example. If a of I is matching with the item, then so what you need to do, as we have discussed already, that your element is founded, you need to stop the search process. For that purpose, we are going to say a break, right? What is the use of break? Break is used to stop the searching process. Either you can use another word like exit, okay, or you can say return. So any of these words you can use here. Okay. So again I repeat it: break or exit or return. These three statements can be used within the loop. That is the searching process. Okay. Now what you say? End of if. This means if your element is found, then you need to stop the search process, and if it is not found in the first location, then obviously we have to go to the next location, which is implemented by set I is equals to yes I plus 1. Okay. So just take a look. I is 1, then incrementing the I, that is you are going to move to the next location. I is 1, then 2, then 3. It will be continue and continue until we reach to the n element, nth element. Okay. Now what you say? End of while process. Okay. So after this closing of block, finally we have to give the result. I mean we have to give the message. So here we are on step 4. Okay. Over this step 4, you need to specify whether you are successful or unsuccessful. It means if you find element or not. So here is a trick, that is if I is matching with the n, then okay. Now the result is mentioned at if I is less than is equals to n, then. What do you mean by that? Look, what was the I? I was your location, like first place, second place, third place, and what was the n? N was the number of element. If your I is less than the n, this means your search is successful, right? So we need to give the message using the display command. Okay, that is element found. This is very common. Okay. Otherwise, you need to say display the search operation is unsuccessful. So for that you can use solid key. Okay. Simply we say end of if. So this is a final step. Now your algorithm is going to finish. So put your keyword like end, or you may also use stop keyword, right? So you can see these steps are very simple. Let's take a look. You can begin from the start, take your location, that is always from the beginning. This is just because we are going to implement linear search. Okay. Then you need to specify the steps that until you not reach to the nth element, and keep comparing your element with the list location. Okay. If it is found, then you need to break the statement and continue to increment your locations. Okay, until it reaches to the last element. Finally, when you are out of the iteration steps, finally you have to show the result or test case. Now as a final round, we have to show the dry run, right? What is the dry run? You mentioned some steps here. You need to show that your algorithm, your logic is going perfectly. For that purpose, we have to test. Okay, so we have taken a list. Now take a look that we have an array A. It consists of 5 elements, right? The first element is 10. The second element is 20, 30, 40, 50 and so on. We are not meaning with the whatever the value is, okay? But we need to be very clear that the location is first. First location is numbered 1 and so on. So you can say the n is 5, right? So these value can be linked with this algorithm, okay? Now what are you looking for? That is item 30, okay? So let's start with the process. As we said that I is 1, okay? So I is 1 means we are going to compare our element with the first element of our items, right? So take a look that we have mentioned here I is less than equal n. What is the value of I? Supposed to be 1. According to our dry run, n is to be considered as 5, right? So 1 is less than equal 5. Yes, it is true. So this step will be performed. Now let's check that A of I is equal to item. That is, what is A of I? So we are in array A and A having I, that is first location. I is 1, so here it is 10. So I can mention here that this process will take the value of 10. And what's the item? Item is 30. Now you can check whether you find the element or not, right? It's very simple. So 10 is not equal to the 30. So we can compare like this. Okay. So this is not true. So we have to take this step I plus 1. This will now come to the second location. Hopefully you understand that. Now we are going to compare with the second location. Again it's a false. So A of I becomes 20. That is 20. 20 will be compared with the 30. Again the condition is false. Then you can say I plus 1. Then it is compared to the next element. Now you can see that operation of comparison is true now. Okay. So when you are going to compare list with your item and by chance if it is found, then the operation will be taken as break, or you can say exit, or you can say return. Done. So you have to stop this process. So what is the value of I? The question is that, because when you are going to locate your element, somewhere you find that and you need to stop the process. So process is stopped, then the value was I of 3, right? We stopped here. Now this operation is finished. Final step is there, step number 4, which says is I is less than equal n. Yes, it is true. So you can say element is found, which was very common. Okay. So this dry run shows that you have the element. Now suppose if the element is other than 30, for example we say 300. So you can see the element is not present in the list like 10, 20, 30, 40, 50. All the values are compared. I will be continuing to increment, right? How I is incremented? 1, then 2, then 3, then 4, then 5. Okay. As a final step, it comes to the 6, right? So we can say I is 6 less than equal n. That was 5. Okay. So 6 is less than equal 5. The condition is false. So what do you say? Sorry. Sorry means the element is not found. So that is you need to specify with each and every algorithm. The dry run is very important. Okay, but I mean when you write down the steps, you can write down your steps in your language and you need to show it with a dry run. Okay, so that's all for today. Thank you.